All right, so let's play around with some of this stuff in Java. So I'm going to work in Eclipse because we need to import lots of libraries. We need to add lots of try-catch blocks, and these are cases where having an IDE will make us faster. So I'll call my project server demo, and I'm not going to do any GUIs here. I'm just going to run this from the console window. So I'll just make a new class, and I will just call it main, and I'll let it go ahead and create a public static void main for me. And so here's our main program, and let's go ahead and start making some code. So I'm going to start off with a server socket. And if we look at the documentation for a server socket, it gets constructed with a port number. And when we do that, it will basically create a socket, bind that port number, which is part of its address, bind that port number to the socket, and then it's available to, if we run the accept method, wait for incoming connection requests and then accept those connections. So let's go ahead and create our server socket. So I'm going to declare it up here, and I'll go ahead and import that class while I'm here. And I'm going to construct a new server socket. And I have to give it a port number. I tend to use port 1201 for no particular reason. You can use more or less any port number you want, but if you're not running as root, you have to have a port number above 1023. So those first 1024 ports, those are reserved, and you have to be root to open a socket with those addresses. But you can use more or less anything from 1024 to 65535, as long as it's not already in use. So 1201 is generally not in use, so I'll go ahead and construct that. And it's underlined because it needs to be in a try-catch block, so I'll say surround it with a try-catch block. And if we get an exception, I'll just say return and kick out of there. So now SS is a server socket, and so now I can say ss.accept, and that will wait for a connection to come in. And again, that has to go in a try-catch. And if the try-catch fails, I will just go ahead and return. And if it succeeds, then I'll say we got a connection. And I'm just going to exit at that point. So we're just going to see if we can create a connection to this server socket. So let me go ahead and run this. And you can see it's running because I've got my red square there, which I could hit to terminate the program. And I'm going to come over here, and I'm just going to use our telnet command, and I'm going to telnet to localhost, which always means your local machine. And if I connect to port 1201, it makes a connection, and my Java code says got a connection. So it succeeded in creating a socket that was listening for connections. Telnet connected to it. This program exited right away, and then Telnet said, oh, connection was closed by foreign host, by the machine that I was connecting to. But that's the beginning of everything we need to do, is being able to make a server socket and then connect to it. And if I were to try to connect again, it's going to say connection refused. There's nothing out there listening on that port anymore. But if I run this again, and then I try to connect, it'll go ahead and connect. This says I got a connection, and then it exits. Alright, so let's look at this accept method. You notice that accept actually returns a socket. So it says a new socket is created, and that socket is the thing that is returned. So it listens for a connection. and then when a connection is made, it creates a new socket and connects that socket to whoever tried to connect to it. So we can do the following. Instead of just calling accept, we can say socket sock, and I'll import the socket class. And then in here I can say sock equals accept, and then down here when we got a connection, let's print out this socket object called sock, and it will have a print a toString method which will give us some information about the connection. So now we're sitting out here, we're running, we're waiting for a connection. Let's go ahead and do our telnet, and it says got a connection, and it says the address was 127.0.0.1. Well, that's the address of this machine that I'm sitting on that's trying to make the connection. Alright, well, we should note at this point that this truly is networked, right? So let me go ahead and run this again. So it's waiting for a connection, and I'm going to hop into a different machine on my local system. So this is a machine 192.168.0.137. It's a Minecraft server, and the machine that I'm running Eclipse on, the machine that I was logged into, was 192.168.0.175. So from here I can telnet to that address, and I'll go to port 1201, and our Java program sees the connection request, accepts it, but it says, you know, this connection was made from 192.168.0.137. Well, that's the host address of this machine that I'm on, exist. If I do an ifconfig command, I can see that's the address of this machine that I just SSH'd into. And you know, it created its own socket with its own port number and connected to the server socket. So this is, you know, something that truly works across networks. I guess I can keep that in there. We can keep doing this cross network for fun. Alright, so we can accept a connection on the socket. What do we do with that connection? Well, let's look at the documentation for a socket. Socket is an endpoint for communication between two machines. It's this bucket that we can put information in and pull information from. We don't need to create a socket because the server socket accept method is giving us a socket. But once we have a socket, what can we do? We can get what's called an input stream, and we can get an output stream, and these are things we can connect to a scanner and a print writer to do I/O. So let's play with that. So we've got our socket connection. Let's read from the socket. So input stream, let's just make a scanner. So we're going to make a new scanner, and when we try to make a scanner, remember we can construct with just, you know, system.in to read from standard in, or we can scan from a new file, but we can also scan from an input stream. And so if we do that, we're going to be able to set up a scanner to listen to our socket. So we can say socket or sock dot get input stream, so this creates a scanner that we can use to read information that's sent to the socket. So let me import the scanner class, and this can throw an exception, so we'll put a try catch around it. And if something goes wrong, we'll just return. Now let's read from the scanner until it hits end of file. So while sc.has next line, So we'll use the scanner's next line method. And I'm just declaring a string. I don't think we need to do that, but we'll go ahead and we'll print this out. And we'll say socket received. And I'll print out the line, and I'll put it inside angle brackets so we can see what it actually received. And then there's the end of our loop. And we'll say the scanner closed, and we'll just print a message down here saying socket closed. And then we'll just exit. Alright, so let's go ahead and run this. So it's hanging out here, it's waiting for a connection. I'm going to go on to my remote machine. I'm going to telnet to the machine Eclipse is on. I'm going to use port 1201. And it's going to say got a connection, and it didn't close this time because now we're sitting in here in this scanner has next line. So I can say this is a test, and when I do that it says socket received, this is a test. And I can say hello world, ha ha ha. I can just hit an enter, and I put a space in here by mistake, so we're seeing an extra space in the beginning. And then I can say goodbye. So when you use telnet, if you hit Control C, it just sends a Control C. So if you want to get out of this, what you can do is you can hit a Control right bracket, and that brings you to a help menu, and you can type a question mark to see helps. And if I just hit an enter, it brings you back to the connection. But if I hit Control right bracket, I can hit a Q for quit, and when I do that, my program notices, hey, the connection's been closed, socket closed, and then it terminated. So we've got good one-way connection going here using a server socket. We can also respond by opening up a print writer. So let's make a print writer so we can send to the socket. So we'll make a print writer PW. Let me go ahead and import that. And PW equals new print writer sock.get output stream. And that's got to go in a try catch block. And if it fails, I'll just return. Now, I'm being really sloppy with my try catches, right? Ideally, I would do something different if my accept method fails, or if my get input stream method fails, or things like that. But I'm not expecting any failures, so I'm just printing out the stack trace and then returning. So when we receive a message, let me get rid of this stray space here. We can say print writer dot print line tell me more, and let's make it slightly more interesting. Let's make an integer here, name count. Let's print out the message number that we just received, and then say tell me more, and we'll bump up count just so we can see how many times we've exchanged messages. So all we've added here is we created a print writer, and after we receive a message, our program here will tell us what we received, and then it will send a message back through the socket which says tell me more. So if we do this, we can say hello, and it says I received a message hello, cool, and I received cool, but where's your output? Right, why is it not telling me this message, tell me more? Well, this gets into an aspect that we usually don't worry about with outputting to standard out, which is the idea of buffered output. And most output is buffered when you use a print writer and you do something like print line. The output is not immediately sent. It's held up in a holding buffer in memory until there's enough information there to make it worthwhile to flush the output. Now if we're sending the standard out and we print a new line, that automatically causes the output to be flushed. But in general, when we're outputting to just an output stream like something we got from a socket, the output is still buffered. So what we're going to do is we're going to say, hey, let's make sure we actually send the output through the print writer, and that's just the flush method. So pw.flush, and if we run this and we do our telnet connection and we say hello, it'll say tell me more. Well, it's a long story. Okay, and you can see that each time it gets a message, it's sending me another message back with a different number in the front, so we know it's actually resending these messages. And I can send an escape key, and it gives me this funny symbol, which if we were to zoom in on it, it's actually a 001B. Well, 1B is 16 plus 11, that's 27. That's the ASCII code for escape. If I send a control A, it gives me a 0001, ASCII code 1, that's a control A. If I do a control B, it'll say 0002. So, this will theoretically send, any kind of information that we want. It doesn't just have to be printable characters, but it can be printable characters. And over here, we can send information back. And then when we're done, we can do control right bracket and a Q, and that closes the connection on this end. And then our Java program says socket closed, and it exits. So that's one end of the connection, the server side. What we need to do is talk about the client side, and that's going to be the next class. Let me give you one more piece of information that can be useful at this point. So let me go ahead and run this program so it's listening on port 1201. So there's another useful command called netstat. This should be on the Linux server. I don't know if it comes by default. If it's not installed, you can sudo apt install netstat. And netstat basically shows you connections on your machine. And established connections are ones that are currently in place. This connection at the top, see, there's a lot of stuff going on here. This connection at the top had a state of time wait. That was the connection to my other machine when I SSH'd in. When I exited, that connection takes a little while to go away, and so it's in a time wait state. But these are all connections that are currently active, and if we do a netstat-a, we can see active connections, so connections that are established, as well as connections that are waiting. And this first column shows us the type of connection. There's a lot of these Unix connections. So let me do a netstat-a and pipe into grep for anything with TCP in the beginning of the line. And this will give us less to look at. And so we've got a handful of connections out here. Well, one of these connections will be right here. We've got a listening connection on port 1201, and that's waiting for incoming connection requests. Now if I terminate this program and then I do this netstat again, 1201 should no longer be listening. It'll either be in the process of shutting down or it will be completely gone. So 1201 looks like it has gone away. So netstat can be useful when you're monkeying around with sockets to get a view of what's going on at the system level. And if we do -an, it will give us raw addresses instead of these symbolic names. NIC desktop, it'll give us 192.168.0.175, and that's also a lot faster. It's the address lookup that's taking a long time. So anyway, netstat's a useful command to see what's going on. Alright, that should do it for our videos here. Next class we'll start developing the client side. We'll look at two-way communication, and we'll break down the general client server model.